Welcome friends. Today we'll be seeing first chapter of 11th standard NCERT syllabus from mathematics. First chapter is about sets. So let's see what is the definition of a set. Set is nothing but a collection of distinct elements. So at the right hand side diagram you can see one set which is named as S. There are certain dots in that set which are some dots are red and some dots are blue. So those dots are nothing but the elements of that set. Yes, so a collection of distinct elements is called as a set. So some of the examples of sets are, you can see here example where set contains four letters A, B, C, D. So this is a finite set because it has finite number of elements. Let's see the second example. R is denoted as a real numbers, set of real numbers. So it is an infinite set because there can be infinite number of real numbers in this set. So next thing is, here you can see symbol epsilon. X belongs to S, which is read as X belongs to S. Let me show you. Here you can see X, there is symbol epsilon between X and S. So how it is read? X belongs to S. Symbol epsilon is used as to denote that the element belongs to that set. So epsilon is stands for belongs to. X belongs to S. In this example you can see X does not belong to S, means there is no such element X in set X. So it is read as X does not belongs to S. We have seen the finite set. Secondly, we have seen the infinite set, which is the set of real numbers. Then X belongs to S. X does not belongs to S. So this is just the way of representation. You have to just remember this symbol. Next example is rivers of India. It is a finite set because there are finite number of you can say rivers in India. Next example is the vowels in the English alphabet. What are the vowels? A, E, I, O, U. So these five are finite in number. So this is a finite set. Vowels in the English alphabet, that is A, E, I, O, U. So this will be one set. You can give any name to that set and it will become a finite set because there are finite number of elements, which are 5 only. Let's see further points. The following points may be noted while studying the sets. The objects, elements and members of a set are synonym terms. So when we say certain elements are belongs to certain element belongs to certain set, then you can use different names for those elements. You can say objects, elements or members of a set. They are nothing but the same terms. Second point is sets are usually denoted by capital letters A, B, C or X, Y, Z, etc. Any letter from alphabets you can use. Just use a capital letter to denote a set. Third point is elements of a set are represented by small letters. So whenever you are representing elements of any set, use small letters. These are just conventions that you have to follow, nothing difficult here. So what are the two methods of representing a set? First method is roster or tabular form. Second is set builder form. So these are the two ways you can represent any set. So what are these methods? See friends, sets topic is nothing but you have to remember certain conventions, and there are very few examples which can be complicated. Otherwise this chapter is very simple. So let's see two methods of representing a set. The set of all natural numbers, which is, let's see first example, the set of all natural numbers which divide 42. So obviously these numbers which can divide 42 are has to be less than 42 or 42 itself. So it is nothing but a finite set. So what are the numbers which can divide 42? 1, 2, 3, 6, 7, 14, 21, 42. Okay, so this example, these are the few examples which through which we will see two methods of representing a set. First, first see the let's first see the different examples. Second example here we have is set V. You can see here. So set V is nothing but x such that x is a vowel in English alphabet. Next example is, this is one form of representing a set. We will see it in detail. Next example is A, E, I, O, U. So this is again a finite set. How to read these set V, we will be seeing that in next example. Just remember, this is one of the way of representing a set. So friends, how will you read the set X? Let's see. So whenever you have this form of representation, we will see how to read that one. So V is a set where is a set of all X such that X is a vowel in English alphabet. This is how it is read. Set of all X such that X is a vowel in English alphabet. So see, here we have two forms of representation. So first is a roster form or a tabular form. This is called as roster or a tabular form. You can write any letter to this example. A equal to 1, 2, 3, 6, 7, 14, 21, 42. So this form of representation is called as roster or tabular form. Second example here we have is V. V equal to, V is a set of all X such that X is a vowel in English alphabet. So this is a set builder form. So again you have next example A, E, I, O, U. So this is a finite set written in roster or tabular form. Okay friends, so these are the two methods through which you can represent a set. First example is of roster or tabular form, and second is of set builder form. You have to just remember how to read these sets. How to read the set builder form. V is a set of all X such that X is a vowel in English alphabet. So let's see a few notes. These are all points from your textbook. You can refer your textbook also, from which is provided by NCERT. So next point is, in roster form, the order in which the elements are listed is immaterial. Thus the above set can also be represented as 1, 3, 7, 21, 2, 6, 14, 42. So these are the numbers which can divide 42 perfectly. So you can write the numbers in any order. It doesn't matter in you can say roster form, but in roster form an element is not generally repeated. That is, all elements are taken as distinct. For example, the set of letters forming the word school is. So if you want to write the letters in the word school in tabular or roster form, how will you write it? You have to write in a bracket. You have to use this type of bracket only, this specific bracket. Always use a curly bracket while you are representing any set. So let's see how to write the letters in the word school. First write the curly bracket, and in that bracket write the letters. So here you have ESCH. Now you have 2 times letter O, so you have to write it only one time. Next letter is L. in generally in roster form you don't repeat the elements. Okay, so here the order of listing elements has role relevance in tabular form. These are some conventions that you have to remember. If you are representing any elements in a set, then you need to be specific about how you form that set. So in tabular form there are certain rules which you can use to form the set. In tabular form the order of elements doesn't matter, and in general the elements are not generally repeated, so you have to remember that. Let's see the next point. Now these are the few examples which are already there in your textbook. We just need to, you can say, we'll try to explain it in simple language. If you have any difficulty you can always put that in comment section. We'll try to improve our lectures. We have just started this series. Okay, so first example is write the solution set of the equation x square plus x minus 2 equal to 0 in roster form. So this is quadratic equation. How to solve the quadratic equation you have already studied that. This is one of the simple form of quadratic equation. So what is the solution? X minus 1 into x plus 2 equal to 0. So x equal to 1 comma minus 2, this is our answer. So you can represent this set in a curly bracket. You can write a equal to 1 comma minus 2. So this will be set of the solution for this quadratic equation. Okay friends, this is first example is simple one. You have to just find the solution for the quadratic equation and write that solutions in a curly bracket 1 comma minus 2. So this is in tabular form. Let's see the second example. Write the set x is, second example is in set builder form. So how will you read this example? So this set is nothing but set of all x such that x is a positive integer and x square less than 40. This is how you have to read it. Set of all x such that x is a positive integer and x square less than 40. So you have to write this in roster form. This is given in set builder form. You have to write it in roster form. So first write the curly bracket, start the curly bracket. Now positive integers whose square is less than 40. So try listing all those numbers. 1 2 3 4 5 6. Up to 6 the square of the number is less than 40. Square of 6 is 36. If you add 7 then it will be square of 7 is 49, which is greater than 40. So it violates the second condition. So here we have two conditions. The number has to be a positive integer as well as its square has to be less than 40. So these are all positive integers. Okay, and their square is also less than 40. So there are only 6 elements in that set. So this is a finite set written in roster form. This is the simple example. Here you have been given two conditions. Set of all x such that x is a positive integer and x square has to be less than 40. So you can write these 6 elements in a curly bracket. Now third example, there are only around 5 examples. After that you can solve the first exercise on your own. This is the simplest one exercise. By using these 5 examples you can solve that exercise on your own. Probably we won't be taking that exercise because some examples you have to solve it on your own, then only you will be able to learn. If you have any doubts you can always put those in comment section, or you can send us an email. We will try to reply as soon as possible. Okay friends, now the third example. Write the set A 1, 4, 9, 16, 25 in a set builder form. So this is in roster form, you have to write it in set builder form. So try to observe the set and observe the properties. So if you observe these numbers, you will be able to see that each number is square of a positive integer. Okay, so 1 is square of 1, 4 is square of 2, 9 is square of 3, and so on. So how will you write? So this has to be written in a set builder form. That way you don't have to write, because this is an infinite series. You can see 3 dots at the end. So set A, x, set A is nothing but set of all x such that x is the square of natural number. See, there are all the positive integers and all are natural numbers. So if you observe, if you read this as set of all x such that x is the square of, up to this point you can easily guess the property. Write down a equal to, in curly bracket, set of all x such that, these 2 dots are, you can read as such that, set of all x such that x is the square of, you can see square here, each number is square of some number. So x is set of all x such that x is the square of a natural number. You have to remember these 2 properties here. Is the square of, you can really guess that these are the squares of numbers. So x is the square of a natural number. So here you have to always remember types of numbers also. What are the prime numbers, what are the natural numbers, what are the complex numbers, and other types of numbers. So if you read those, then you will be able to define any set. If you have given a different example, then you will be able to identify those numbers as well. So alternatively, how you can write this? A is nothing but set of all x such that x equal to n square, where n belongs to capital N. So here again 2 properties are defined in 2 different forms. Set of all x such that x is a n square, n is some certain natural number where n belongs to n. So n belongs to n, capital N is denoted for set of all the natural numbers, and small n is used for certain specific natural number. So the natural number belongs to larger set of all the natural numbers. These are the 2 ways you can represent a set in set builder form. X is the square of a natural number, or in alternatively you can see x is set of A is set of all x such that x equal to n square, where n belongs to capital N. Okay, so what is the important point here? You have to identify 2 properties, that it is a square of certain number and it belongs to a natural number set. So these 2 things you have to remember. Different types of numbers you should know. You can make notes of different types of number on single page and try to remember the different types of numbers. Alternatively, if you are okay with this form also, you can write, instead of in words, you can write it in equation or symbolic form also. Square of certain number, so you have to write x equal to n square, and natural number, then where you can write n belongs to n. So this is also acceptable. This is the easiest form. Let's see the 4th example. So here you have to write the set. Here fractions are given: 1 by 2, 2 by 3, 3 by 4, 4 by 5, 5 by 6, and 6 by 7. So you have to write these examples in set builder form. How you are going to write this? Set of all x such that x equal to n divided by n plus 1, where n is a natural number and 1 is less than n less than or 1 is less than or equal to n less than or equal to 6. So here friends, you can observe that denominator is greater than numerator by 1. Okay, in each of this example you can see denominator is greater than numerator by 1. So here we have assumed the letter n, which represents the numerator. So set of all x such that x equal to n divided by n plus 1. If you put n equal to 1, you will get 1 divided by 1 plus 1, which is nothing but 1 by 2. If you put n equal to 2, then you will get 2 by 2 plus 1, which is 3, 2 by 3. So this way you can get all the elements. So what is the second condition here? Our numerator is 6. We don't have numerator greater than 6. So where n is a natural number and it is 1 less than equal to n less than equal to 6. So here the two properties are used. The numbers used in these examples are natural numbers, and the numerator is between 1 and 6. Either it has to be 1 has to be less than equal to n, or less than, and n has to be less than equal to 6. That is, numerator has to be between 1 and 6, positive integer and a natural number. Okay, so those two properties are written here, where n is a natural number as well as 1 less than equal to n less than equal to 6. So this is the way you can represent this example in set builder form. So you have to observe two properties here, that numerator is less than denominator by 1, or denominator is greater than numerator by 1. So this property you can use here in, you can say, equation form, x equal to n divided by n plus 1. Second thing you have to remember is n has to be in this form always, that is 1 less than equal to n less than equal to 6, because we have numerator between 1 and 6. Okay, there is no value of n greater than 6. So these are the two things you have to remember in this example. So now let's see the fifth and the last example. Match each of the set on the left described in the roster form with the same set on the right described in set builder form. So here you have to match the pairs where the same set is represented in two different forms. You have to identify that set. So in first example here you can see letters are represented in a, you can say, tabular form, PRINCAL. So this seems to be the spelling of word principle. So try to match this example with the right hand side sets. So the set D here, x is thus that x is a letter of the word principle. So you can see all the letters in the principle word can be represented in tabular form in set 1 of left hand side. So you can match example 1 with the set D. Okay friends, so here you can see the letter I is not repeated. Here we have I letter twice in the word principal. So you might remember that we have studied that in tabular form we generally don't repeat the elements of the set. Okay, now let's see the second example. Second example is, you can say, null set, because it's a 0 in that set only. So let's see which set can be matched. If you observe the set C, x set of all x such that x is an integer and x plus 1 equal to 1. So if you try to find the value of x plus 1 equal to 1, so value of x will be 1 minus 1 0. So you can match these two. Third example is 1 2 3 6 9 and 18. So let's see the set A here. Set of all x such that x is a positive integer and is a divisor of 18. So you can see these are all positive integers. Already we have seen this type of example previously, and is a divisor of 18 also. So for we have seen this example for number 42 at the start of this lecture. So this one is similar to that. So all numbers are positive integers and divisor of 18. If you observe, all these numbers can divide 18 perfectly. 1 2 3 6 9 and 18 can divide a number 18 perfectly. So these two properties are easily fulfilled here. So set 3 can be represented by set A. Now the last example, fourth one, 3 comma minus 3. So if you see this example, set B, set of all x such that x is an integer and x square minus 9 equal to 0. So you can see here there are two integers, 3 comma minus 3. So first property is matched. Now second is x square minus 9 equal to 0. If you solve this equation, you will get two solutions, 3 comma minus 3. Already you have seen how to find the solution of quadratic equation. So solution of x square minus 9 will be 3 comma minus 3. You can write that in tabular form as 3 comma minus 3. So set of all x such that x is an integer and x square minus 9 equal to 0. So solution of x square minus 9 equal to 0 is 3 comma minus 3. Always remember how to read this type of set. Okay, how will you read the set builder form here represented? Set of all x such that x is an integer and x square minus 9 equal to 0. Set B is set of all x such that x is an integer and x square minus 9 equal to 0. You can write it down in words and try to remember. So this is all about our first lecture. We'll try to add more lectures for mathematics 11th standard NCERT syllabus. If you have any doubts, you can always put those in comment section. We will try to cover more difficult examples and try to solve the first exercise on your own. If you have any doubts in any exercise or in any example, you can always ask us, and we will try to improve our lectures also. So don't worry about that. You can always ask your doubts. Have a good day, friends. Thank you.